Our next speaker is Peter Chapman, and he is CEO and President and Chairman of the Board of IonQ. And prior to joining IonQ, Mr. Chapman was Director of Engineering for Amazon Prime, where he led the team responsible for Prime's two-day delivery. He also has over 40 years of leadership in software engineering, and he's credited for inventing the original sound cards for computers. In addition to writing the software for the FAA, the Federal Aviation Administration, for their use to prevent mid-air collisions, and for developing systems that protect the integrity of the financial markets. Mr. Chapman has founded and led several companies to successful exits. Please welcome Peter to share the latest developments at IonQ.
Okay, hi everyone, I'm Peter Chapman, President and CEO of IonQ. So today is going to be a little, and my speeches are always a little different. Usually there's a lot of talk about technology and gate speeds and all sorts of things. But today what I'm going to do is talk about how to build a large billion-dollar quantum business. And so we're going to do a mass NDA. So everyone raise their hand and please agree not to tell any of our competition, and make sure you hold it just inside this room. Actually, it was kind of interesting, you know, this at Quantum World Congress, at night there's all these dinners, and I had a young entrepreneur come up to me from Europe and ask, you know, kind of for advice on how do you be successful in quantum. So I hope he's here to listen to this, because this really is in response to that. So today's presentation is split between myself and Dean. And so one side is going to be business and one side's technology. So about 10 minutes in, he'll talk about some of the technical milestones that we've achieved. First, I want to say that I do think that quantum is accelerating much faster than most people thought it would. And I think most people don't realize that technology doesn't grow linearly, it grows exponentially and builds on each other. However, having said that, every day I hear about a new breakthrough in quantum. That word is probably a little overused right now. I don't know if you agree, but it seems there's a lot of noise in quantum, and maybe for the first time I'm not talking about the hardware, but instead the business. So today I'm going to use my time to go to take you on a journey from that word breakthrough all the way to $1 billion business. And we'll do that in 10 minutes. And hopefully for people that are here that are thinking about doing a startup in quantum, this will be a useful conversation. Okay, so one of the things about being a public company is you get slides like this. So what this basically says is I'm about to make, and Dean, so a bunch of forward-looking statements before you invest in IonQ stock. You should definitely read all the potential pitfalls before you invest. I'm not going to read this slide to you. That would take 10 minutes. But if you are thinking of investing in IonQ, there is a copy of this on the website, so make sure you read that before you invest. So today I'm going to talk about scale, but not in the way that you probably think. This is to talk about how to scale a quantum computing company to get to $1 billion. And then Dean will talk about scale in terms of how to scale the hardware, the normal reference to scale. Okay, so let's go back. I'm going to use the Wayback Machine and go back to 1995 when IonQ had its, quote, kind of breakthrough. IonQ wasn't even in existence. This was Chris Monroe at NIST with others who did the very first quantum logic gates. And that was kind of the breakthrough moment. That was 1995, so that's roughly 30 years, right? 29 years ago. So from that breakthrough to today is 29 years. But I'm going to zip forward 10 years, and you get to basically the very first seed round that from that initial breakthrough to the first seed round and the beginning of IonQ. It actually took a year from the seed round to actually getting to the first employees. So from breakthrough to then 10, 11 years. Then from 2016 to 2021, we raised 2 additional rounds, VC rounds, and we created multiple versions of the hardware itself. I think 5 generations of hardware in that time, almost entirely in an academic setting, meaning that these systems were lovingly bespoke, put together by quantum physicists inside a laboratory at IonQ. When I joined the company, there was no intention of the board told me, don't worry about selling systems, don't worry about the competition, just build the best hardware, and that's what we did. And that in turn gave us confidence during those years to actually come up with our first roadmap. And so, you kind of now we're, 15, 16 years now already in this process from the original breakthrough. So next, if we look at the next couple of years, in 2021, we took the company public. We were lucky, we had no sales at that time. Strangely, most companies, when they go public, they usually have about 100 million in sales. But we managed through, the way the market worked, to be lucky to come to the market and raise a great deal of money. And what did that money allow us to do was to really go from these academic systems and now start thinking about engineering and how to start building products, quantum products, not kind of basic R&D. And so, I'll give you some strange things. Until just recently, we did not have a complete set of engineering drawings for our quantum computers that you could hand to the production staff to build it, to reproduce it, or for that matter, to be able to give it to a contract manufacturer to be able to develop. So it's amazing, in these early days, how it really is an academic environment and now going to a production one. So this is a progression now going from an academic phase to now an engineering phase and actually starting to think about how to build product. And then the next step was to build a management team. And so we started hiring people who have a background in producing products and being able to sell them at scale. And then finally, with Seattle, to actually start to build out a manufacturing plant that could actually assemble the systems that we're building based on the engineering drawings that was done by the original physicists and engineers. And so, and we got to a huge milestone, is that quantum computers now built at IonQ are not built by physicists, because we want them to be working on the next generation systems, not doing, assembly line work out back. So, and of course, when you start to actually ship product, you need to do little things like, scaling your sales team internationally, build a field service organization. And who's going to support that machine in Japan that you just sold? And can you break your machine down into parts and put it into shipping containers and then ship it across the world and reassemble it easily? These are all the kinds of things when we talk about getting to scale are the things which most people don't think about in quantum. And of course, you need to make your customers happy. You need repeat customers. And so I'll take a little off-ramp just for a second to highlight some of the most recent events along this journey so that you can kind of see these events in terms of the context. So as we just heard from Daryl, is we signed a repeat renewal with the University of Maryland, and it continues our strong partnership to make Maryland a quantum economy together. And so we're very happy to be partnered with the University of Maryland and continuing that strong partnership. The next aspect is if you look at the customers that we work with, Hyundai, I think we're on our, fifth or sixth project together. Airbus, GE, and many others. As Daryl mentioned, we just did a large contract here in Maryland with the IC community, and now to do blind quantum computing for the first time. And then we also announced recently a renewal with Amazon Bracket. So it's particularly important if you're going to go get these customers to make sure that they're happy and that they're wanting to come back and actually do repeat business with you. Then the next announcement is we've shipped now to Rome, New York, one of our quantum computers. And that is now it's assembled, and we're now starting to do calibration on it. So shortly, that will be running jobs for AFRL. So this is an example of actually shipping product and actually having it reassembled at the other end. And then the next one is, you probably saw the announcement that we have shipped another system to QuantumBasel, and that's in final assembly. And now we'll start doing calibration, and by roughly December timeframe, it should be up and running jobs for customers. So these are examples of, and by the way, these systems are not being done by physicists. They're now being produced by people out back who are on basically an assembly line. Not quite yet to the way Henry Ford did, but we're getting there. Okay, so let's just talk about the sales aspect of this. So the orange line that's on this graph is our bookings. And so, for the layman, you could say those are sales. It's not quite the same as recognized revenue. IonQ is now, this year, is quickly approaching $100 million in bookings, which is a huge milestone for any company. This would normally be the place where you'd think about going public. And it's a huge milestone also for the quantum industry. We're showing that quantum is actually a business. And we've done it in record time. So if you look here, in roughly 4 to 5 years, we'll have gone from 0 to 100 million. If you go and look on the internet and pull down data from the largest companies, how long did it take them to get to 100 million? So I used ChatGPT. Hopefully the data is correct. It wasn't having a hallucination. And it said that it took Microsoft about 10 or 11 years to get to the same place. And so the quantum business in IonQ is growing at the same kind of rate as some of the largest classical companies that are out there today. And so we're quite excited about that process. And if you're going to be a small cap growth company, you better have strong growth. And so IonQ has been, in bookings, has been roughly doubling them every year, and more than likely will continue to do so into the future. So the question is, how do you get from 100 million to $1 billion? So that's just the last piece I want to talk about. Of course, you need to have international sales and to be able to generate revenue. You also are going to need an application. This is the thing that we've all been waiting for. An application that can deliver value and being used by Fortune 1000 companies, and hopefully within an entire industry that can unto itself generate billions of dollars in revenue. And in fact, at the upcoming earnings call that we have for IonQ, we will talk about the first of many applications that we think we will be able to do in our upcoming hardware. And so it's a really exciting time, because finally we're going to get to the place in the NISQ era to applications that can now deliver that kind of value. So that's how we plan to go from 100 million to $1 billion. But I'm going to just talk about that application. If we're going to generate $1 billion in sales with that application, how many quantum computers do you think you need? 1, 2, 10, 50? So obviously, you're not going to generate $1 billion on a single quantum computer, probably not 2 or 3. And so if you're going to generate $1 billion and you need 50 quantum computers, you better be able to actually manufacture 50 machines. And you're going to have to sell those machines, so the cost per qubit better be a hell of a lot less than it is today, because people aren't going to put out, $10 billion for that application. And so, a secret which is hiding in plain sight is that to get to scale of $1 billion, you have to scale up all the other parts of the business, not just the hardware. And I think in some sense, IonQ is pretty unique because that's exactly what we're doing right now. We're scaling up the manufacturing for the application that's going to need tens, if not hundreds, of quantum computers. I heard another quantum computing company just recently said that they were going to get to $2 billion in 2026, and they haven't shipped their first system yet. And so how the hell will you go from there to hundreds of machines in 18 months or 2 years? So when you're thinking about scale in quantum, make sure that you're thinking also, how do you scale the business to go along with scaling the hardware? Okay, and then lastly here is just to point out that we're now powering numerous areas today in their quantum economies. Many of these locations are approaching their $100 million mark as well in terms of investment that is going back into their local economies. And then, the question is who's next? And hopefully it'll be some of you, and that will be something that we can talk about shortly. And with that, I'm going to hand it over to Dean.
Thank you, Peter. So Peter was able to talk a lot about the kind of the business side of things. I'm going to switch gears and kind of quickly cover some of the milestones. So once again, I'm Dean Kassmann. I'm Senior Vice President of Engineering and Technology for IonQ. So my background is actually engineering. I joined IonQ when we went public. And so a lot of the path that Peter just talked about kind of falls on my shoulders. I run all hardware and software at the company. All AMO physics kind of rolls up underneath me. And so all of the engineering design from kind of early concept to actual delivery and handoff to manufacturing is underneath my purview. And so Peter talked about kind of enterprise grade and those pieces. I'm going to kind of switch gears and talk about kind of performance and some things on scale. So I want to cover some of the recent technical achievements on our path as we've been moving forward. And so our North Star is a balanced approach between these different pieces because you need all of these to be able to achieve what Peter just described. So let's jump to scale. So scale is our North Star, right? We build scale through both modularity as well as all of the other engineering best practices that we have in place. One of the key contributors to scale, and we've talked about this before, is the ability to connect QPUs together. QPUs in a single machine start off as in trapped ions as a single linear chain in our architecture and move to multi-core. You then go from multi-core QPUs to connected multi-core QPUs. And so we have talked about a set of milestones in our overall kind of path to connecting QPUs that I show here on the slide. Now that slide kind of starts off in kind of the thinking of some kind of analogy as local area networks, right? First of it's a single point, then you get to point, and eventually you have kind of many-to-one connectivity. So you start in terms of the way our systems connect QPUs with being able to kind of use photons and trapped ions together to emit a photon that is entangled. That entangled photon with that ion represent kind of being able to move off machine to be able to connect or off QPU to the other QPU. The second milestone then takes those communication or interconnect qubits and then connects them. That establishes a quantum link between the two machines, at which point you can then execute a swap gate, which is not a native gate in our systems. It's made up of several fundamental gates. But that swap gate is then allows you to connect the QPUs together. Now, the final stage or the final milestone is being able to do this in kind of a mesh topology, a larger network topology, We've shown 4 milestones here, but there's actually many, many more that we can insert kind of to provide additional color. So today I'm happy to announce that earlier this month, the team at IonQ kind of was able to hit milestone 2. This is a major breakthrough. So being able to establish that quantum communication link, we're actively working on driving to the next milestone and being able to switch and actually have 2 connected QPUs. We're trying to eventually get to that kind of initial remote CNOT gate. The beauty of what we're doing is it doesn't require cryogenics. It's at room temperature. It does not require exotic kind of changes to our architecture or anything else. So the next piece I want to cover is performance. And so on performance, there's 2 quick things I want to cover based off of time. The first has to do with barium. And so we've been making continuous progress in our barium technology. We chose barium for some of its intrinsic benefits, including higher native gate fidelity, some of the wavelengths that it operates at. And so we've demonstrated 99.939% fidelity in barium on one of our barium development platforms. That was done with a 50 microsecond gate time. And so this is a huge breakthrough. It kind of validates it does validate the overall approach that we have with our development systems as we move towards Tempo. So Tempo, which is the product that we talked about last year on this stage, has been in the work for a while. The work here in barium kind of demonstrates the viability of that technical path as we continue to kind of break down and go through each technical wicket after the next in terms of delivery. The other piece I want to cover real quickly is recent work that the team did on quantum error correction, right? We have a great team at IonQ. They're an amazing set of scientists, physicists, and engineers, software engineers. Recently, we published a paper on arXiv, as well as published out a blog post that is trying to bridge the gap between where current hardware is across the industry and full fault tolerance. And it's a partial error correction approach. It takes a common class of noisy gates called Clifford gates and proposes a method to be able to reduce the noise for those gates. And so this is kind of a tool in the toolbox to use in addition to error mitigation methods and other techniques to be able to actually drive value for customers. And it's one of the things that we're using as we move forward to do just that. There's links here on the bottom to be able to access those papers. They're welcome to take a look. I'm happy to answer additional questions on this. But I want to close here because I'm over time. And so I want to thank everybody for listening today. We're really excited about being able to kind of talk to you, the path that we're on. You're welcome to learn more about our systems at IonQ Get Started. You're also welcome to kind of learn about some of our customer success stories, some of our technology at our resource link. And so with that, I want to thank the organizers for having Peter and I on stage. Very much appreciate it, and I'll conclude. Thank you.